So welcome to part 2 on Code of Chaos. In part 1 we explored some of the foundational concepts about malware, explaining how it's created, how it spreads, and some of the early types of malware. And an important thing to kind of reiterate is that malware often blurs the line. So when we talk about different characteristics or features of malware or behavior, we talk about them in isolation, but in reality most malware actually has multiple aspects and does more than one of these things. So now we're going to be looking at some more malware variants, how they use stealth, deception, and even cryptography to evade detection. So let's get into it. So a very interesting type of malware is something called the Multi-Partite Virus. And this is a type of malware that basically infects a system in multiple ways at the same time or in sequence. So it can target something like an executable file and also the system's boot sector. So this multiple kind of attack or infection strategy evades a system that would just have like a single layer of defense. And because it attacks two areas of a system at the same time, it kind of highlights a need to have a defense in depth approach to securing a system. Another interesting type of malware is a stealth virus. So these are actually really interesting and really cool, and a lot of malware does this. But essentially what it does, it actually manipulates the operating system to conceal the presence of the malware. So it basically tricks your antivirus, anti-malware solution into thinking there's a clean scan, there's nothing on the machine. And what it does is it kind of hides in plain sight and evades like signature-based tooling. There are ways around this if you look at kind of heuristic or behavioral type of analysis that can be crucial to kind of catching stealth infection, as opposed to kind of relying purely on signature-based detection. But ultimately a little bit of both is what's needed. Another really cool type of virus, and I love this because it's just so clever, it's actually called a polymorphic virus. And this virus essentially is constantly shifting the signatures. So it's a bit like a shapeshifter in a way. It retains the same kind of malicious functionality, whether it's trying to steal data, corrupt your system, or just access something it's not meant to be. But what it will do is kind of scramble its code, so it produces a new signature or a new hash each time it replicates and infects a system. So it's basically trying to outrun your detection capabilities. If you think of this like infecting a computer or a group of computers, let's say there's 10. The first computer it infects will have a particular type of signature. When it moves to another computer, it will have a completely different signature. So if you're scanning in the exact same way on the first computer, on the second to 10th, it would look clean. But in fact, all the computers could be infected. It just has a completely different type of signature. Now, fortunately, cybersecurity defenders have got better at analyzing these kind of programs and don't just rely on static kind of footprints. They can look at the behavior of a system or a process to better detect these things. But it still remains like a really difficult thing to deal with in most cases. Another really cool type of virus is something called an encrypted virus, which basically scrambles its code to evade scans. So instead of mutating or changing its like underlying logic or code or trying to produce a different signature or hash, what it does instead is each infection uses a different cryptographic key, causing the virus to look a little bit different on each system. And there will be a small virus decryption routine that kind of remains visible because it has to decrypt the rest of the encrypted virus, but the rest of the malicious payload stays encrypted on the disk. And what security tools can do to look at this is looking at and studying the kind of decryption routine and using that as a kind of signal of something to look into. Another really interesting type of attack is something called a logic bomb, and essentially it's like a hidden trigger waiting to execute. And there's been a couple of times this has been used on companies. So let's say there was someone that was let go, a developer, a system admin, someone with quite a lot of access to the company, and they're a bit disgruntled about being let go or made redundant. What they've actually done is they've left a piece of malicious code or malware to execute at a specific date or time, their last day. And it's quite an interesting use case of it. It just basically delays something from happening, and it's not always time-based. It can wait for a very specific trigger or behavior to occur on the system to kind of launch and execute. But yeah, these things can delete files, steal data, corrupt databases, and so on and so forth. Of course, there's Trojan Horses as well. Trojan Horses essentially is like a piece of software that you download and it looks legitimate. It looks like something that isn't malicious, but in fact it is. And again, a lot of these attacks can be used in conjunction with others. So Trojan Horse type of attacks tend to work very well in crypto malware, which is malware designed to basically mine crypto, Bitcoin on your computer. And what they'll try and do is hide as much of that as possible so they can mine for as long as possible to make the most profit for the attacker. And then there's botnets. And botnets is like a zombie horde. Essentially, it's a bunch of compromised computers that can be used and combined to launch an attack on a specific system or a website, and essentially it's used in kind of distributed denial of service attacks, DDoS attacks, or to send like large scale phishing emails or spam, and again can be used for other things like mining cryptocurrency. And of course the way the botnets are compromised can be for various other types of malware. Now worms are probably some of the most dangerous kind of malware out there, and what makes them so dangerous is they don't normally rely on something or someone to spread. One of the most devastating cybersecurity attacks that we know about, called NotPetya, used this worm-like functionality to basically crawl systems, crawl networks, and just infect everything without anyone doing anything. They have the kind of trait of once they're inside, they just spread fast. Now you do have some other types of malware that aren't as invasive, such as Adware, which basically bombards you with unwanted ads or redirects particular users or set of users to another website for financial gain. These can slip through unnoticed and aren't usually super harmful. But then you've also got something like spyware, where people can literally listen in, log your keystrokes, or look at you through the camera, and can be very problematic in that way. One of the last ones I want to talk about for this video as well is zero-day attacks. And I think it's very important to understand these types of attacks. And what they basically do is they take advantage of a vulnerability that is not known yet by the vendor, by the system owner, and they're very hard to deal with because it's the first time that attack takes place. It's the first time seeing it, or the attack is so new that the vendor hasn't actually been able to fix the issue yet, but the systems are still vulnerable to it. And these type of attacks take, a very kind of strong defense in depth, cover all your bases, a lot of monitoring and logging and looking at behavior and what normal looks like on a network or on a system, and trying to look for the abnormalities within a system. So this boosts the likelihood that you'll stop a 0 day, but can't really guarantee it. So yeah, that's just a quick kind of insight into malicious code, malware, some of the things we have to deal with within cybersecurity, and some of the behaviors associated with malicious code. And one of the best ways to protect yourself from these attacks, hackers, data breaches, and everything else is actually by using good security tools such as Proton VPN. Now there are so many VPNs out there, but what I really like about Proton, and I actually use this myself and pay for the service and promote it to anyone and everyone, is that they're a security conscious kind of company. All their products are based around security. They have the most secure emails, VPNs, password managers, and just generally their files and drive and sharing, everything's so great. A lot of it's open source, so you can literally look at the code for yourself. It's fast, effective, super cheap, and if you get the Proton Unlimited, you can get so much different features, and yeah, it's just amazing. And one of the reasons I actually kind of know, and I've always known, that it's one of the best security kind of companies / tools to use is that hackers use it. Malicious hackers and ethical hackers, and also people who do a lot of dark web research, because you don't necessarily need to be tied into an identity or have all your personal information uploaded to be able to create something. You're kind of one step removed from having your privacy leaked, even if there was a breach. So yeah, they're a super cool company and I love what they do, and I will be linking them in the description, so check that out below. Please like, comment, share and subscribe, and I'll see you in the next one.